So first concept we will cover here is the cryptographic hashing function. So as I told, cryptographic hashing is a function, but it is a one-way function. So one-way function, that means which is irreversible function. That means reversing the function is very difficult. What is irreversible? So for example, if we have a function, so it will take some input from the some domain, and it will output some in the some domain. For example, these domains may be different. Domain in the sense, so for example, x will be belongs to some numbers, for example 1 to 10, y might be belongs to some 11 to 100 something, or 1 to 100 something like that. For example, a function, how can you define a function? So you will have some input x domain and also some domain for output y. So you will have some numbers 1 to 1 so on 10, and also something like 1 to some 100. So if you give some 2, it will output to some number. For example, it will be some 14 or something. If you give some 10, it will give out some value in the output domain. So this is the function definition which we see in the schooling. So in this case, what is irreversible function? That means if you give, for example, if you have f of x equal to x square, is it reversible or irreversible? Can you tell me, anyone, please? I think you have understand, you know the basics of the reversible and irreversible. For example, reversible means if you have output y, then you can get input, right? That is the meaning of the reversible function. But if you have a irreversible function, that means if we have a function f of x which outputs to y, so you need to get x as f inverse of y. This is the meaning of the reversibility of a function. So irreversible in this sense, this is not possible. Reversible means this is possible. Irreversible means this is not possible. So hash function is a one-way function, that means which is irreversible functions, that if you know the output, you cannot compute the input. That is the meaning of the irreversible function. Can you tell me whether this function is reversible or irreversible? No, I think I have already written the answer, right? It's a reversible function, right? X square is a reversible function, but you cannot. I will tell you one basic example for the irreversible function. For example, if you have two inputs, x belongs to some domain 0 or 1, which is binary, and y also belongs to some domain, same domain. And if you want to compute and, do you know the and function? So and is a function which takes two inputs, x and y. It will give some output. So if it will take two different output with the different combinations 0 0 0 1 1 0 and 1 1. There are four possibilities, right? With the two different we have only 0 and 1 for x and y, so we have four different possibilities: 0 0 0 1 1 0 and 1 1. So and is a function, oh, and is a reversible. Okay, 1 minute, I will take r function. So the function r is the output of the function r is 0 whenever both inputs are 0. If any one input is 1, then the output will be 1. So for example, here 0 1, y is 1, that's why it is 1. Here 1 0 is 1, and also it is 1, right? Did you got it, or do you have any questions? So now what I will do, I will give some output. Can you tell me the input? So for example, you know this basic definition of r function, and also I will give some output to you. I don't give input to you. For example, from this basic understanding of the r functions, if I give output as 0, then you can easily tell input as x equal to 0 and y equal to 0, right?
What if you put it as 1?
Sorry, yeah, that's why I'm going to do it. Suppose if output is 1, so there are three different combinations, right, which are not predictable, right? The probability of correct answer will be out of these three options, you will get one third probability, right? So you cannot predict which is the correct output. So there are three possibilities, either 0 1 or 1 0 or 1 1. So this is so since the getting input from the output is probabilistic, or it is not deterministic here, So that's why this is a irreversible function. The R function is a simple example for the irreversible function. Okay. Do you have any questions now?
So any one of those possibilities can come
Yeah,
in.
any one is possible, but exactly you don't know what exact output, right?
Oh, okay.
Okay, any one is possible. There are different possibilities. So here it is a simple function. For example, if you take a multi-input, for example, if you take 5-bit input like x1, x2, x3, x4, x5, and if you want to compute R out of this x1, only one possibility, all zeros will give the zero. So rest of the things like here there are four possibilities, two inputs, 2 square equal to 4 possibilities. Here 2 to the power of 5 is 32 possibilities. 32, the table consists of the 32 elements. So out of the 32 elements, you cannot predict which is the input. If I give output as the one, it's very difficult to predict input for the output one. So because there are 31 possibilities here. Even if you take 10-bit input, it will be 2 to the 10, which is 1024. So out of the 1023, you need to predict the input. So if we increase the number of the bits, the difficulty will be increased to predict the input for the given output. So that is way this one-way function is defined. So it consists of not exactly the R function. It consists of different combinations of the different functions. The algorithm to understand the cryptographic hash function will consist of a compression function and running that compression function for multiple times. And after running some 60 times or 80 times, depends on the cryptographic algorithm. So that will give some output. So you will have this kind of R function, AND function, XR functions, and also there are a lot of other different functions will be exist in the cryptographic hash functions. So all those binary functions will be executed for 60 times in a loop. Then after running for the 60 times of those kind of the operations, it will give some kind of the output, which is the cryptographic output. To make that reversible is very difficult. That is that way the cryptographic hash function was defined such that it should be irreversible. So I'm just giving a simple example here, but it's a cryptographic hash function is a similar kind of irreversible function. Yeah, that is also a similar thing. For example, here I can explain here, and is also same kind. So if we have inputs x and y, you have output 0 0 output will be 0, and 0 1 output will be 0. 1 0 output will be 1. The and will be the output of the and function will be 1 only when both all the inputs are 1, right? This is
Yes,
the
sir.
reverse of
Mhm.
R function. So here you can easily predict the 1. So for example, if I give output 1, then you can easily give the input x equal to 1 and y equal to 1. But if I give output as a 0, so there are different possibilities similar to the R function, either 0 0 or 0 1 or 1 0. Is
Yes,
it correct?
yes, sir.
So similar kind of example for the reversible function. So this is a simple 2-bit AND function. But if you take n-bit function, for example, in most of the cryptography will used in 256-bit. 2 to the 2 to the power of 256 is very big number. So in that kind of very big numbers, if you want to predict this kind of the input, if you want to reverse that input functions, very difficult.
Yes, sir.
Okay.
Mhm.
So another thing is ensure data integrity and tamper proof. Like so, we have already seen that we have already discussed that we are using the hash functions to save the hash of the previous function in the current block, right? So in the block header, we will have the hash of the previous block header. So, yeah, so we will hash the previous block header and we will make it into the current block. That way, it is tamper proof. For example, in the current block, in the previous block, suppose some malicious user wants to change anything in the previous block, then the entire block header will be changed because the block header consists of Merkle root of all the transactions. So block header will be changed. If block header is changed, the output of the hash will be changed. So if output of the hash will be changed, then everything need to be changed. So if a malicious user wants to change any particular transaction or anything in a particular block, then he need to change everything from that particular block to the current block. For example, currently we are in the 100th block. If a malicious user wants to change a transaction in 90th block, he needs to change the transaction, then he needs to change the header of that particular 90th block. If 90th block header is changed, then that previous that block header, that block hash will be used in the 91st block header, right? So he needs to change that previous block in the 91st block header. Then also he need to change that 91st block hash will be saved in the block header of the 92nd block header. And also similarly, 92nd block hash will be saved in the 93rd block header. So this is a chaining process. So in the chaining process, if you want to change any particular block in a previous stages, then you need to change all the blocks till current block. That is very difficult with this irreversible function. That's why it is a tamper proof. That's why this hash function will be used for the tamper proofing of digital records. Okay, we will see how it will be happen while discussing the block header and block transactions. Okay. So we will define this hash function as a block box, something like here it's a binary function. It's a binary function means it will take binary inputs. Like just now we have seen and or functions are binary functions, which will take the inputs as zeros and ones. Similarly, hash function will take binary inputs in terms of the zeros and ones. For example, for example, if I want to give some message like hello, for example, hello, so it will convert this hello into ones and zeros. For example, H will have some, it's a, if you take the ASCII values, in the computer knowledge, if you have, for each alphabet, there will be some ASCII value. For example, A, B, C, D, E, F, G, H. So A has the 65, B 66, 67, 68, 69, 70, 71, and 72. For H, I will convert this H 72 into binary value. So ones and zeros. So it will take time to do all these things. So I will just simply write some for example, I will convert this into some 8-bit number, something like that. I will use some 1 0 1 0 0 something like that. So 1 0 4 0 1 8 0 0 0, and this is 16, and this is 32 and 64. 64 I need a plus 8, so I need to use here 1. So this is the way representing H in the digital in the binary format. Okay, so what it will do, so this H will be 0 1 0 0 0 0 0 1 0 0, and also there will be some similar kind of value for the E and L. All this is a binary format, something like that, 0 zeros and ones, something like that. It will be in some binary format. So the input I am giving for this is, let's assume input as a X. So we can give some binary input which is arbitrary length. So there is no limit for the input length in the for the hash function. So did you understand what is this arbitrary length, variable length? For example, I can give hello, I can give uh, hello, 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 something like that, or I can give some message. I can give a big string, like big number, anything I can give, which is a variable length. Some message will be 10 bits, some message will be 100 bits, some message will be 1000 bits. It may be variable length. We can give any length of message as input to the hash function H, and we
But
can get.
this, so if how many times we write hello, the same like scheme of letters is not going to come, right? It's going to be different.
It will be different. The stream of the numbers will be different. The input will be different.
Always.
Yeah.
Okay.
It's not same. I will show you. You can test it in the code while doing the hands-on experience. We will do that. I will let you know how to do. Suppose if we give the hello, the output will be one thing. So if you add something else to this hello, then the output will be completely different. You cannot even predict that output, which is very random. So for example, if you give one as input, you will get some number. If you give two, you cannot expect the immediately next number in the output also. It is very random. So you can easily observe that while writing the code. By writing the code, you can explore all these things. So then the properties of a H function you can explore. So the output will be fixed, which is here n equal to either 128 or 256, which should be in terms of two powers of the two, something like that, 512 bits. We will see the examples of 256, which is used in the Bitcoin, which is SHA-256. SHA-256 is a cryptographic hash function used in the Bitcoin, which can take any length of input and also output only the 256-bit length output, which is fixed. So did you got it? So here it is a irreversible function. So if you give a 256-bit number, 256-bit output, you cannot predict the input. You cannot compute the input, which is called irreversibility, which is because of the irreversibility property of H. Okay.
So what is the star mark like?
Yeah, it's a star means it's a variable length. It's not a fixed.
Okay.
Okay, a
Okay.
star represents it's a variable length.
Okay.
Okay, so this 0 to 1 n star means it's a star means that length. Here in the output you can see n. N is the length of the output. You can see maximum of 256 bits, either zeros or ones in the output. Okay.
Yes, sir.
Okay. So here you can give any length. What you can give hello, you can give your name, or you can give whatever very big length of message, whatever you want, you can give as an input to this hash function. But output will be fixed length of n bits. Okay. So example is a SHA-256. This outputs only 256 bit hash. Example, if it will give hello, it will give in terms of this. But this is to write it in bits. It's it will be very lengthy. That's why it will be represented in terms of the hexa. So you know how to convert bits to hexa or whatever it may be. For example, in the hexa, each so binary. 1 minute. So in the blockchain field, most of the things will be represented in the hexa field. That's why I will explain a little bit about that. So binary means you will have only zeros and ones. Okay, binary field. We can just simply represent it as a F2. Okay, binary field can represent it as a F2 field of two values, either 0 or 1. So this hexadecimal values can be represented with a field of 16. It is from start with 0, 1, 2, up to 9. After 9 it will start with A, B, C, D, E, F. So either it may be small or capital, whatever it may be, A, B, C, D, E, F. Okay. So how this connection between this binary and hexadecimal number? 0 can be represented in terms of the 4 bits, 0, 0, 0, 0. 1 can be represented with 0, 0, 0, 1. 2 can be represented with 0, 0, 1, 0. So how do you know how the conversion between hexadecimal and any other conversion system? Do you have? I think you have this conversion number conversion system in your school syllabus, I guess. Do you know how to convert a given number into a binary or binary to a given decimal number? Anyone?
So you're clacking to me. Can you say that again, sir?
So do you know how to convert? So we have a different number systems, right? Binary number system, decimal number system, hexadecimal number system, octahedral number system, something like that. So do you know how to convert from one system? If I give a number, I will tell in what system it was. Then do you know how to convert into another system? I will bit explain it. So for example, 1010. This is starting with so it is zeroth position. This is first position, second position, third position. So how we can convert this into? First we will start with zeroth position. First we will start. It will be 0 times 2 to the 0
Is it
plus
right?
1 times 2 to the 1 plus 0 times 2 to the 2 plus 1 time 2 cube. So if you add all these things, it will be 10. So this is the way to convert from binary to decimal. So what we will, this is very basic thing. I think you might have in the, I don't know whether you have in even in your syllabus or not,
Yeah.
but it's,
So, students, are you following this? Basically, every number, every digit, every word can be converted into binary numbers, which means everything can be expressed as zeros and ones only.
yeah.
Yeah? Are you following this, everyone? I would
Yeah.
like to see some of you. Please just switch on your cameras.
Yeah,
It's
please.
orienting. If you don't switch on your cameras, it's like we are talking into nothingness. So switch on your cameras, please. Mannat, Ayushi, Ian, your camera is not there, but Mannat and Ayushi, I would love to see you and have an experience of having a proper engagement. Yeah, Mannat, thank you, Ayushi.
Yeah.
Mannat, are you there? I Anyway, so what my question is, do you understand that anything can be explained in zeros and ones? This is what is we are talking about right now. Yeah. Okay,
Okay, fine.
so yeah, you're following this.
Yeah.
Okay. So in other way around, if you want to convert 10 to 10 number 10 to binary, how can you do? You can do a simple division algorithm. For example, it will divide. So 10 can be divided with 2 by 5, and the remainder will be 0. And if you again, it's a continuous division. So if you divide again 5, it will go 2 times of 2 will be 4. Then you will get a remainder of 1. And again with the 2, it will be 2 times, it will be 1 time, 2 will be 2 times 1 will be 2, then the remainder will be 0. Again, if you again divide with 2, there will be quotient will be 0 and remainder will be 1. So we got 1 0 1 0 as the binary in the reverse order. So you need to take from the reverse order. 1 0 1 0 is the output. It's if it is in the 10 in the 10 decimal system, you will get 1 0 1 0 in the binary system. Did you understand this? So this is the very basic thing to how to convert from the one number system to the other number system. Similar way, in the computer language, everything will be converted into the binary system. But we can, for user interface, like if you want to understand it more clearly, you will see it in different format on the screen. Like for example, if you write a uh, for example, here you are seeing your name as it is, like Ayushi Patra. But in the inside the computer, while this Zoom app will do everything in the binary. So it will take your name as binary. The A will be converted into the binary. Y will be converted into the binary. So it will take all the inputs to binary, and it will give access to your account. Then after giving the access, it will whatever the options you choose, like choosing the camera, choosing the video, or choosing the camera option, or choosing mic, everything will be turned on. Then you how your name will be displayed, everything will be done, will be that is a user interface that will be done in the general English language. So but everything will be processed inside the computer will be in the binaries, not in A will be not like I she A Y U S H I will not be uh, work as it is in the computer language while giving the access to you. So everything. So for example, in this hash function also, this hello, if we give the hello as the input, the output will be something like 2CF, something like that. So how I will do that in the binary? So in the binary, output will be 2 will be 0 0 1 0, and C will be what? C will be, it's 10 11 12. 12 means 1 1 0 0. F means all ones, 1 1 1. 2 means again 0 0 1 0. Again 4 means 0 1 0 0. D means it's a 13, like 1 1 0 1. B means 11, means 1 0 1 1. A means 10, it's 1 0 1 0. 5 means G 1 0, like 0 1 0 1. So and so on. This way, it will generate the output in the binary format. But for the user interface, it will be shown as hexa number 2CF24, something like that. Okay.
So how did you convert that? Like, is there
Just
somewhere
now I
it's
told you, right? Just now I told the converting this 10. So if you see
okay?
this continuous division algorithm for converting the number systems, first you need to divide the 10 with the 2. So the quotient
Mhm.
will be 5 and
I understood that
yeah.
part, but I did not understand the letter part. Like, how do we convert
Later,
the
on,
letter?
if you see this hexadecimal field F16, you have 0, 1, 2. This field consists of 0, 1, 2, 9, and also
Mhm.
the letters A to F. It is total 16 characters. The field F16 means it consists of the 16 characters in the hexadecimal, which is A, B, C, D, E, F. A will be 10. We just write 10 as a. So, for example, in this field, you cannot write, for example, 2. If you write C as a 12, how can you see 12? But while reading, it will be something look like 2 1 2, not a 2 12. You don't know whether it is 1 2 is a separate number or 12 is a combined number, right?
Yeah.
That's why it will be represented with letters. After ninth digit, it will be represented as a letter in terms of A B C D E F, only for those 6 letters. Okay.
Okay.
Okay. So you can say A as a 10, B as a 11, and C as a 12, 13, 14, 15.
Yes, sir.
Okay.
And what is SHA 256?
That's why SHA-256 is a function. It's a cryptographic hash function, which is an algorithm used to convert an arbitrary length to 256-bit output. So if you give arbitrary, here you are giving the hello as an input, you
Mm-hmm.
will convert it to 256-bit in output. This entire number I have just shown dots at the end, but it's a complete 256-bit number. That means 256, each character in this output will be a 4-bit binary. Like 2 will be 0010, which I have written. So it consists of only 32 characters. 32 characters in the sense 32 into 4, not 30, 64 characters. 64 into 4 is 256. So in the hexadecimal, it will be written as 64 characters, but in the binary, it will be shown as 256-bit number.
And bit hash is the unit, like
No, no, no.
BIT bit.
No, it's a 256-bit.
Okay, bit is the number of.
256-bit is a output number of the bits in the output. It's a hash.
Okay.
As I'm saying, it's a hash. This is a hash function. That's why I'm reading as a hash.
Okay.
Okay. So it's a output consists of the 256-bit hash function. I need to write it a hash function. Otherwise, it's a hash function. Okay. Is it fine? I will modify it while sharing with you.
Yes, sir.
Okay. It's a hash function which outputs 256-bit. Okay. This is an example which can take any input value, but it will output 256-bit binary or 64 character hexa. Okay. Anyone has any question regarding this definition of hash function and this example of SHA-256? So just think as a SHA-256 as a block box. Inside it consists of some SHA-256 algorithm. It's a function, irreversible function. It will take an arbitrary input and it will output a 256-bit output. Okay. Is it clear?
Yeah.
Mannat and Ian, are you following
Yes, sir.
this?
Yeah.
Yeah, just
Yes.
think it as a function. SHA-256 is an example of the hash function. So this is one kind of hash function. Mostly we will use in the blockchain. Most of the blockchains will use this function. Otherwise, catch, that is a different function. So as of now, we will just discuss about SHA-256 for understanding purpose. Okay, is a hash function. It is you think this box as a block box. Inside there, some commands will be run. There is some instructions will be run, like some OR functions, some XOR AND functions, XOR functions. There are different kind of the binary functions will be run within this algorithm, SHA-256 algorithm. It will take some input of arbitrary length. Star means it's arbitrary length. It's a not fixed length. It's a variable length, and it will give only 256-bit output. Okay, is it clear?
Yeah.
Uh,
So
Feel
this
free
is
to add.
only
Yeah,
used for passwords, right? Like mainly used for passwords and like just integrity checks, like all of that.
yeah, exactly. Hash function will be used for integrity check.
Okay. Okay.
Okay. So actually, for example, in the centralized systems, for example, any mailing system, for example, if you want to log in with your email ID, your password will be stored as a hash output in the server. For example, if you take a Gmail or any other mail or in a bank account or something, you need to create your password, right, while registering with that email ID. You will get some user ID plus password. User ID is your email ID. Password is something like whatever you keep with some specifications or whatever they mention. Something. So, for example, they will instruct you something like there should be at least one capital letter, there should be at least one letter, and there should be at least one special character. So with all those combinations, you will create your own password. That password will be stored as a hash function in the server side. Suppose, for example, while you log in into that account, after entering your username and password, that password will be converted into hash, and it will be checked with the hash output which is stored in their server. If those two outputs match, the hash of your entered password and that stored password, that stored hash output of that password stored in the server is matched, then you will get access. Otherwise, if it didn't match, then you will be rejected that authentication, right? Something like that. In that is also one example of hash functions. Yeah, any other queries?
All right.
Yeah, we will move further. Okay. So the application of this tools blockchain is used in the blockchains for linking the blocks. As I told already, the hash of a previous block hash, the hash of the previous block header will be stored in the current block header. That way, it is for linking the blockchain blocks. This hash function will be used, and also this will be used in the digital signatures. So we'll see soon how this will be used in the digital signatures, and also it will be used to compute the Merkle root. So we will see that application also.